Go on, do me a favor. Take a look at your hand. Really look at it. The color you see right there, it tells an incredible story. It's a story about a journey, about survival, and about where every single one of us comes from.
But that brings up a huge question, right? If we're all one species, Homo sapiens, how is it that we look so incredibly different? I mean, why is there such a vast range of appearances if we all supposedly came from the same ancestors? Well, the answer is kind of like a detective story, and all the clues are written in our DNA.
To get to the bottom of this, we have to go back in time. And I mean way back. Picture this. It's 300,000 years ago, somewhere in Africa, where our species first walked the Earth. Back then, things were simple. Every single human on the planet looked more or less the same. They were all dark-skinned.
Yeah, for the first, 240,000 years of our story, that was it. One shade. This wasn't some random coincidence. It was actually a brilliant piece of evolutionary design.
And the secret ingredient? A pigment called melanin. You can think of it as nature's perfect built-in sunscreen. It's like having billions of microscopic umbrellas inside your skin that soak up the sun's harmful UV rays. And living near the equator, under that intense African sun, well, having a lot of melanin wasn't just helpful, it was absolutely essential for survival.
See, the sun is a real double-edged sword. On one hand, too much UV radiation is seriously bad news. It obliterates a nutrient called folate in your body, which is absolutely critical for healthy pregnancies. But on the other hand, you need sunlight on your skin to produce vitamin D, which is just as critical for building strong bones. So our dark-skinned ancestors had the perfect balance. Their skin blocked just enough UV to protect their folate, but still let enough in to make that vital vitamin D. For hundreds of thousands of years, this system worked flawlessly. But then, about 60,000 years ago, a few small groups of humans did something that would change our story forever. They started walking out of Africa. And they were carrying this amazing adaptation for the sun that was about to become a huge problem. As they pushed into places like Europe and Northern Asia, you can see this happening around 45,000 years ago. They walked into a totally new world. A world with a weak, watery sun that was often hidden by clouds for months at a time. The farther north they went, the less sunlight there was. And this set the stage for a new, invisible, and very, very dangerous challenge.
So the biggest threat wasn't the cold or the mammoths. It was the sky. That dark skin, the very thing that had been a lifesaver in Africa, was now blocking too much of the weak northern sunlight. Their bodies just couldn't produce enough vitamin D. This wasn't a minor issue. It was a full-blown biological crisis, a life-or-death problem.
Okay, let's break down just how devastating this was. First, the low sunlight and dark skin meant vitamin D levels just crashed. When that happens, your bones don't develop properly. This led to diseases like rickets in children, causing painful, deformed bones. But here's the absolute killer. For women, a pelvis deformed by rickets made childbirth fatal. An entire generation was at risk of dying out. The pressure was on. Adapt or disappear.
Now, you have to remember, evolution doesn't have a plan. It just works with random mutations, basically tiny genetic typos. And it just so happened that in these struggling northern groups, a few of these random typos gave some people a massive survival advantage. And this is the part that I think is just amazing. It didn't just happen once. In Europe, a mutation in a gene called SLC24A5 led to lighter skin and spread like wildfire. But on the other side of the world, in East Asia, a totally different set of mutations in genes like OCA2 did the exact same thing. This is called convergent evolution. Two different groups, two completely different genetic fixes for the exact same problem. Incredible. And get this whole change is ridiculously recent. The light skin we associate with Europeans only became common about 6,000 to 8,000 years ago. That means white skin is newer than farming. It's newer than pottery. It's one of the newest features in the entire human story. So let's pull all these threads together. Because when you step back and look past these very recent and frankly superficial adaptations, our genetics tell an unmistakable and pretty powerful story about who we really are. 0.1%. That's it. That is the tiny, tiny fraction of our DNA that's responsible for all the visible differences we see between people. Skin color, hair type, eye shape, all of it. It's all packed into just 1/10 of 1% of our genetic code.
Which means this number
is how much DNA you share with every other human being on this planet, 99.9%. Genetically, you are 99.9% identical to every single person you will ever meet.
So what is our DNA screaming at us? Well, a few things. First, all those differences we see, they're brand new, and they're literally just skin-deep adaptations to the climate. Second, it means that race as a biological concept just doesn't hold up. It's a story we invented, not a reality written in our genes. And finally, it proves we are all descended from that exact same small group of African pioneers. We are, quite literally, family.
I love this quote because it puts it so perfectly. Your skin isn't a wall separating you from others. It's a living map of our shared human journey. It's a record of the incredible challenges our ancestors faced and overcame so that we could be here today. So, when you look at another person, you're not seeing someone different. You're seeing another chapter of the same story. You're seeing the proof of our resilience and our shared origin. So that leaves us with just one question, doesn't it? If our skin is a map of the past we all share, what kind of story are we going to write for the future we have to build together?